In the silent void between the stars, a tiny machine sails, Voyager 1, humanity's farthest messenger. It carries a golden record, our music, greetings, and a snapshot of Earth. For nearly 50 years, Voyager has been our silent ambassador to the cosmos. Just as we prepared for its final silence, Voyager sent back a mysterious message, a faint, puzzling echo from the edge of our solar system. This isn't just about a machine, it's about our relentless curiosity and drive to explore. Voyager's images transformed our view of the cosmos, revealing worlds we'd only imagined. Its final, enigmatic transmission reminds us, the universe is still full of surprises. The Voyagers are more than metal and wires, they are our eyes and ears in the deep. They've survived radiation, freezing temperatures, and outlived all expectations. This last message is a fitting farewell, a riddle from the void, igniting our imagination. Science thrives on the unknown, and Voyager's final whisper is perhaps its greatest gift. Even at the edge of our reach, the universe finds ways to surprise us. Voyager's story began in the 1960s, when NASA scientists made a groundbreaking discovery, a rare planetary alignment known as the Grand Tour, that would allow a single spacecraft to visit multiple outer planets using minimal fuel. This extraordinary opportunity comes only once every 176 years, making it a true, once-in-a-lifetime event for humanity and space exploration. The mission was ambitious and daring. Build spacecraft capable of journeying to Jupiter, Saturn, Uranus, and Neptune, all in one continuous voyage. No one had ever attempted such a feat before, and the stakes were incredibly high. To meet this challenge, NASA engineers designed and built two identical probes, Voyager 1 and Voyager 2. These spacecraft had to be robust enough to survive more than a decade in the harshest, most unforgiving environments of deep space, far beyond the reach of the sun's warmth. Solar panels, the usual source of power for spacecraft, wouldn't work so far from the sun. Instead, the Voyagers relied on radioisotope thermoelectric generators, nuclear power sources that would keep their instruments running for years, even in the cold darkness of the outer solar system. Their onboard computers were primitive by today's standards, with less processing power than a modern calculator. Yet, these early computers guided the spacecraft with astonishing precision, navigating billions of miles through the vastness of space. The mission was a tremendous gamble. No one knew if the probes would survive Jupiter's intense radiation belts, or the complex series of gravity assists required to reach the outer planets. Every step was fraught with uncertainty and risk. Gravity assists or planetary slingshots were the key to the mission's success. By carefully flying past each planet, the Voyagers gained speed and changed direction, allowing them to leap from one world to the next on their epic journey. Voyager 2 was the first to launch, blasting off in August 1977, followed closely by Voyager 1 in September. Their journeys began with a roar, carrying humanity's hopes and dreams into the cosmos. The mission's success depended on flawless calculations, tireless teamwork, and, as always in exploration, a bit of luck. Every trajectory, every maneuver had to be perfect. As they traveled, the Voyagers transformed distant points of light into detailed worlds. They mapped mysterious moons, measured alien atmospheres, and sent back breathtaking images that changed our understanding of the solar system forever. The Grand Tour became a testament to human ingenuity, vision, and the relentless pursuit of knowledge. It showed what was possible when people dared to dream big and work together. Against all odds, the Voyagers pressed onward, becoming our first true pioneers into the vast unknown beyond our solar system. Their journey redefined what was possible in space exploration, inspiring generations to look up and wonder what lies beyond the stars. The Voyager's journey transformed our understanding of the solar system, opening up a new era of exploration and discovery. Before these spacecraft, much of what we knew about the outer planets was based on distant, blurry images and speculation. The Voyagers changed all that, bringing the solar system into sharp focus. In 1979, they reached Jupiter, revealing the Great Red Spot as a raging, centuries-old storm, far more dynamic than anyone had imagined. They also discovered active volcanoes on Io, the first ever seen beyond Earth, proving that our solar system was far more geologically active than previously thought. Europa's icy surface, crisscrossed with mysterious cracks, hinted at a hidden ocean beneath, raising the tantalizing possibility of life beyond our planet. Saturn's rings, once thought to be smooth and uniform, were revealed as thousands of intricate ringlets, with tiny moons weaving patterns and shaping their structure in ways never before seen. Titan's thick, hazy atmosphere was a world unto itself, shrouding the surface in mystery and hinting at complex chemistry that scientists are still unraveling today. Voyager 1's primary mission ended after Saturn, as it left the solar plane and began its journey into interstellar space, carrying with it a golden record of Earth's sounds and greetings. Voyager 2 continued onward, reaching Uranus in 1986. A tilted blue-green world with faint rings and a host of new moons, each with its own unique story. In 1989, it arrived at Neptune, finding fierce, fast-moving storms and photographing Triton's icy geysers erupting into space, revealing a moon with active geology at the edge of the solar system. The planetary phase ended, but the discoveries rewrote textbooks, dozens of new moons, dynamic rings, and active, diverse worlds that challenged our ideas about what planets and moons could be. The Voyagers turned distant points of light into living places, transforming mysterious dots in the sky into worlds with weather, volcanoes, oceans, and atmospheres. Their data is still studied today, inspiring new generations of scientists and fueling ongoing missions to explore the outer solar system. The Grand Tour was an unprecedented success, a feat of engineering and vision that brought humanity closer to the stars than ever before. These missions gave us a new perspective on our place in the cosmos, reminding us of Earth's fragility and unity as seen in the iconic pale blue dot image. The outer planets became destinations, not mysteries, their secrets revealed and their beauty captured for all to see. Voyager's legacy is a solar system revealed, an enduring testament to human curiosity and the desire to explore the unknown. After completing their grand tour of the outer planets, the Voyager spacecraft set their sights on a far more distant frontier, the very edge of the Sun's influence, known as the Heliopause. This invisible boundary marks the end of our solar system's protective bubble, where the solar wind, a stream of charged particles from the Sun, finally gives way to the vastness of interstellar space. The Heliopause is a frontier no human-made object had ever crossed before. Here, the solar wind slows and is overtaken by the interstellar medium, a region filled with particles and radiation from distant stars. For years, the Voyager's instruments carefully measured the fading strength of the solar wind and the increasing presence of cosmic rays, gathering data that would help scientists pinpoint the exact moment of crossing. In August 2012, Voyager 1 detected a dramatic shift. Solar particles all but vanished, while cosmic rays from beyond our solar system surged. This was the unmistakable sign. Voyager 1 had become the first spacecraft to enter interstellar space. Voyager 2 followed in 2018, confirming the crossing at a different location and providing valuable data about the shape and variability of the heliopause itself. Now, as true interstellar travelers, the Voyagers continue to sample ancient dust and plasma drifting between the stars, sending back information about a region of space never before explored directly. These pioneering probes give us our very first direct taste of the galactic environment, revealing the mysteries of the space between the stars and expanding our understanding of the universe. Today, the Voyagers are more than 15 billion miles from Earth, so distant that a single radio signal takes over 22 hours to make the journey each way, a testament to the vastness of space. Their power supplies are dwindling and one by one their scientific instruments are shutting down, ending decades of groundbreaking discoveries. Soon, the Voyagers will fall silent, their voices lost to the void. Yet their journey will not end. They will continue to drift through the Milky Way, silent travelers for millions of years to come. Each carries a golden record, a message from Earth, making them silent ambassadors of humanity, carrying our story and our hope into the galaxy. Even as their signals fade and their instruments go dark, the legacy of the Voyagers endures, inspiring generations to look up and wonder. The Voyager's interstellar mission stands as a triumph of human curiosity and exploration, a testament to our desire to reach beyond the known and touch the stars. Each Voyager carries a golden record, a message in a bottle for the cosmos. Conceived by Carl Sagan, it's a 12-inch gold-plated disc with images, sounds, and music from Earth. The record includes greetings in 55 languages, music from Bach to Chuck Berry, and sounds of nature. Its cover features diagrams showing how to play it, and a map to our sun using pulsars as cosmic signposts. The odds of it being found are tiny, but that's not the point. Creating the record made us reflect on what it means to be human. It's a symbol of hope, a gesture of peace and curiosity. The golden record is our cosmic greeting, art, science, and music sent to the stars. It represents a moment when we reached beyond ourselves. Voyager's message is optimism cast into the void. For decades, the Voyager's faint signals have been captured by Earth's deep space network. By the time they reach us, their power is unimaginably weak, a testament to our technology and persistence. But the end is near. Their nuclear generators are running out. NASA engineers have shut down systems one by one, stretching every last watt. The final plan is to keep a simple carrier signal, a heartbeat, alive as long as possible. Eventually, even that will fade, and the probes will fall silent. They'll become silent ghosts, drifting with their golden records through the galaxy. The team at JPL cherishes every last bit of data. The end was expected to be a gentle fade to black. But the universe had one last surprise in store. Voyager's story wasn't finished yet. In spring 2025, as Voyager 1 neared its end, a strange anomaly appeared. A routine signal was garbled, containing a faint echo of a command sent from Earth. It was as if the probe had bounced a distorted version of our message straight back, something never seen before. Engineers suspected a malfunction, but diagnostics were inconclusive. Sometimes the echo appeared, sometimes not. The timing was odd, too quick for any known reflection. The space around Voyager is nearly empty. Nothing should bounce a signal. Theories range from software glitches to exotic plasma interactions. As of August 2025, the Voyager echo remains unsolved, a final, unexpected mystery. It's a fitting end, not a quiet fade, but a question mark from the darkness. Voyager's last act is a puzzle for the ages. Voyager's legacy is immense, scientifically and culturally. It transformed the outer planets from mysteries into worlds, revealing volcanoes, oceans, and dynamic atmospheres. Its discoveries paved the way for missions like Galileo, Cassini, and New Horizons. The iconic pale blue dot photo, showing Earth as a tiny speck, gave us a humbling perspective. Voyager's images inspired unity and environmental awareness. Experts call Voyager a turning point in human history. The mission's greatest lesson: expect the unexpected. The universe is more creative and surprising than we imagined. Voyager inspires new generations to explore and wonder. Even its final echo is a lesson in humility and curiosity. The universe isn't required to make sense to us. Voyager's last message, glitch or phenomenon, reminds us mysteries remain. Our journey of discovery is far from over. Soon, the Voyagers will fall silent, drifting endlessly through the Milky Way. They'll outlast us, carrying their golden records for millions of years. Their end is not just a farewell, but a call to keep exploring. Voyager's legacy is inspiration, showing what we achieve when driven by curiosity. New missions now reach farther, building on Voyager's discoveries. The final echo reminds us there's always more to learn. As we say goodbye, let's see it as a beginning, not an end. The stars are waiting, and our journey has just begun. Let's keep listening, searching, and exploring. Our place is among the stars. Voyager showed us the way.